So that is the condition. Now, after adding concentrated sulfuric acid, the effervescence will occur, and that means a gas is given out. Now, if you look at the question, they are telling us to also name the drying agent. And the drying agent is right here, because we are saying the gas is then passed through a wash bottle containing, so this is our drying agent, concentrated sulfuric acid, and its role is to dry the gas. And it is, if you look at the question again, they are saying you mention the method of correction. Check the diagram. The method of correction by which hydrogen chloride is corrected is downward delivery. Downward delivery, another name is upward displacement. Downward delivery or upward displacement of air. But I encourage you, always look at the position where the delivery tube is facing. If the delivery tube is facing down, then the method is downward delivery. But if the delivery tube is facing up, then the method becomes upward delivery. So concentrated sulfuric acid to dry the gas, and the gas is collected by downward delivery method, since it is denser than air. If you look at the question again, you were required to write the equation. So the equation for the reaction stands the way it appears here, and this is it. We have sulfuric acid. I'll keep mentioning to you that you remember when we are preparing nitric acid or hydrogen chloride gas, we use concentrated sulfuric acid. And one of the properties of concentrated sulfuric acid we saw some time back is that it is a dehydrating agent, or it is hygroscopic. It absorbs water from atmosphere. Now here it absorbs water from the solution, so there is no water. The salt is sodium hydrogen sulfate and not sodium sulfate. And also hydrogen chloride is formed as a gas. So in this equation, there is no state of aqueous. In this equation, there is no state of aqueous, because sodium chloride we are using is acid, and sulfuric acid we are using is concentrated. Is concentrated, which means it will absorb water and there will be no water formed. So that was it for part A. It required you to mention the conditions. The conditions we have said, sulfuric acid should be concentrated. Then we shall also apply some heat. Shall also apply some heat, and also it required you to mention the drying agent. The drying agent is there, and its method of correction. Method of correction is downward delivery, and that is it. The substance that is formed when hydrogen chloride is dissolved in water, that is what we looked at on properties of hydrogen chloride. And the question that we are referring to is this part: preparation of a solution of hydrogen chloride. We looked at it in the previous lesson, and the solution of hydrogen chloride in water is hydrochloric acid. So preparation of hydrochloric acid, It is prepared by dissolving hydrogen chloride in water. It is prepared by dissolving hydrogen chloride in what? In water. Then name a reagent that can be used. Name a reagent that can be used to correct. Oh, we have not yet reached there. So the substance that is formed when hydrogen chloride is dissolved in water, the answer is hydrochloric acid. Name one reagent that can be used to test for the presence of hydrogen chloride gas. The reagent is silver nitrate and nitric acid. Those who put silver nitrate only, I was crossing it. And the answer, please note this somewhere, the answer is silver nitrate solution. Silver nitrate solution, not just silver nitrate. Because in the lab, silver nitrate appears as a solid. So that's why we endeavor to say silver nitrate solution. We get silver nitrate solution after dissolving silver nitrate in water. So we use silver nitrate and nitric acid. The role of nitric acid is just to acidify the silver nitrate, such that if there are any impurities, they can be dissolved by nitric acid. So that's why we use them together. The answer is silver nitrate solution and nitric acid. That is the reagent. Now, state what would be observed when the reagent was added to hydrogen chloride. The answer is right. Write the equation. The equation is right here. Silver nitrate plus hydrogen chloride gas, we get silver chloride plus nitric acid. This is very common chemistry. Write an equation to show that hydrochloric acid is an acid. This one, we had it here. This is the equation I wanted. Show how hydrochloric acid ionizes in solution. It ionizes to form hydrogen ions plus chloride ions. Remember, when I say show that hydrochloric acid is an acid, remember the definition of acids that you had in senior 2. Defined an acid as a substance which, when dissolved in water, forms hydrogen ions as the only positively charged what? Ions. So when I say write an equation to show that hydrochloric acid is an acid, you write this one, where hydrochloric acid forms hydrogen ions plus chloride ions. And that is it. Name an apparatus that is used to to prepare a solution of hydrogen chloride in water. I expected only one answer, and that is an inverted funnel. Give a reason. Many of you are saying it stops. Your answer, this inverted funnel stops water from flowing back to the preparation flask. This is the preparation flask. So many of you are saying it stops water from flowing into the inverted funnel. Look at how the funnel is. all the water that attempts to go back will be made to fall down again. So this inverted funnel, it prevents this water from flowing back to the preparation flask, because when water flows back, since you are heating, the flask will break. And that is the same case we looked at when we were preparing ammonia. We said you use a slanting, the flask should be made to slant. Then we wanted an ionic equation for carbonate, that was calcium carbonate and hydrochloric acid. The equation is this one, this last one. That is the ionic equation. And the molecular equation, you put here calcium in place of zinc. So all carbonates react with the acids to form a salt. The salt in this case is zinc chloride, then carbon dioxide and water. So that was it for the assignment. We looked at uses of hydrochloric acid. Maybe we look at preparation of hydrogen chloride gas in methylbenzene. So hydrogen chloride gas is formed by covalent bonding. So in methylbenzene, hydrogen chloride dissolves but does not ionize. It does not form ions. Like in water, hydrogen chloride gas forms hydrochloric acid, which forms ions of hydrogen ions and chloride ions. But in methylbenzene, we are saying hydrogen chloride still exists as covalent compound because it dissolves, it dissolves, but it does not do what? But it does not ionize. So let us note this, that in water, hydrogen chloride gas dissolves and ionizes, or it forms ions, that is hydrogen ions and chloride ions. But in methylbenzene, hydrogen chloride dissolves but does not ionize or does not form ions. It still exists as a covalent compound. So if it exists as a covalent compound, you know one of the properties of covalent compounds is that they do not conduct what? Electricity. So a solution, I mean hydrogen chloride gas in methylbenzene, its solution does not conduct electricity. Test for chlorides. Chlorides, when concentrated sulfuric acid is added to any chloride, we will get, but this is not the one I want. I want you to always remember this. Test for chlorides. You remember the solubility rule on chlorides. It says all chlorides are soluble except silver chloride and lead 2 chloride. So if you want to know that there is a chloride in solution, you just add nitric acid and silver nitrate, the same way we were testing for hydrogen chloride. So silver nitrate and nitric acid, when there is a chloride, it will form a white precipitate. And the white precipitate is silver chloride. So that is the test for chloride ions. So you just add silver nitrate solution. If you want to know that there is a chloride, just like when you want to know that there is oxygen, you bring a glowing spring. So if you want to know that there is a chloride, you bring a substance, a soluble salt of silver, and silver will react with that chloride to form silver chloride, which does not dissolve in water, and therefore a white precipitate. So a white precipitate, when you use silver nitrate, shows you that there is a chloride, because silver chloride is insoluble in water. If there is any question, you can ask, and if it is not there, like we agreed, we shall proceed and go to page 305 that I told you. And on page 305, we shall be reviewing our knowledge on organic chemistry. So, organic chemistry, it is the chemistry of carbon. But now I am going to point out only the most important areas. So whatever I don't talk about, don't concentrate on it. That means that one is for senior 5. We shall look at it more in senior 5. And remember, you promised me that you are all going to do chemistry in senior 5. So we shall meet there. So organic chemistry is the chemistry of carbon and its compounds. These organic compounds contain carbon. So I want to take you directly to what we call saturated and unsaturated compounds. Now, when you are doing organic chemistry, you remember that carbon has a valence of 4. Carbon has got a valence of 4. So wherever it exists, it should have 4 bonds. Carbon should have 4 what? Bonds. So it can be attached to other compounds like hydrogen. It can be with nitrogen, it can be with oxygen, but all in all, the carbon should have 4 bonds. So, what is a saturated organic compound? Saturated organic compound is the one where carbon atoms are joined to each other by using a single bond. It doesn't matter what element is attached to carbon, but as long as the carbon atoms are joined to each other by single bonds, that compound is going to be saturated. Now, unsaturated compound is the one where the carbon atoms are going to be joined together by multiple covalent bonds. So when I say multiple covalent bonds, it means bonds which are more than one. It can be 1 bond, it can be 2 bonds. No, which more than one, it can be 1 bond, they can be 2 bonds, and so on. So, e.g., we have ethene. Now, ethene is an alkene, you remember, so it has a double bond between the carbon atoms. We have ethane. Ethane is an alkyne, and alkynes have a triple bond between the carbon atoms. So, where the number of bonds between carbon atoms are more than 1, we call that unsaturated compound. UN, unsaturated organic compound, where carbon is having more than 1 bonds. So that is the difference between saturated and unsaturated organic compounds. So when you look at this again, when you look at this example, I've told you should make sure that carbon has 4 bonds. So these first 3 bonds, when you see CH3, it means the 3 bonds are for hydrogen. Carbon joined to hydrogen, carbon joined to hydrogen, and carbon joined to hydrogen. Now, I now take you to classification of organic compounds, and we are saying the organic compounds All these classes we shall look at them in our senior 5. But for now, you need to know what a functional group is. So a functional group is a group of atoms or an atom that is common to a given homologous series of organic compounds, and that atom or group of atoms is responsible for the chemical properties of those compounds. For example, all alkenes have a double bond between carbon atoms. So when you see a double bond between carbon atoms, that one is a functional group, because it helps you to know that all those compounds are alkenes. All alcohols, compounds which are alcohols, they have a hydroxide group, hydroxyl group, OH, attached to carbon. And this is what I'm talking about. OH group, that is for alcohols, e.g. ethanol, and its formula is this one, CH3CH2OH, methanol. So you are seeing all these alcohols, they have OH group attached to carbon. So OH group now is a functional group. Let us also remember something about homologous series. We are saying this is a series of organic compounds related to each other by the same group. So for homologous series, you have a group of organic compounds but which have the same chemical properties, and they usually have a general formula to which they conform. So what is important? I've told you, let us know that saturated compounds are compounds where the carbon atoms are joined together by a single bond. Then unsaturated compounds, the carbon atoms are joined together by multiple covalent bonds. Multiple covalent bonds, they can be 2 bonds or 3 bonds, like that. So from there, don't read any other thing from saturated and unsaturated. Just come directly to hydrocarbons. So you not somewhere what you need to read about. I think you are not in. Read what saturated organic compounds are and what unsaturated organic compounds are. That's what you need at your level. And from there, we are coming to hydrocarbons, not somewhere. So a hydrocarbon, the word hydro comes from hydrogen, and carbon is carbon. So hydrocarbons, these are compounds consisting of only 2 atoms, that is carbon and hydrogen. That definition you need to know. Hydrocarbons are compounds that are made up of 2 atoms, that is only carbon and hydrogen. From the definition of hydrocarbons, you now mention the classification of hydrocarbons. Now, at your level, you need to know that hydrocarbons are classified into 3 groups, and the groups are alkanes, alkenes, and alkynes. So alkanes, we are going to look at them at each of these ones independently. But for now, we know, I told you carbon should have 4 bonds. So for alkanes, their structure should always look like this. This alkane, carbon has 2 carbon atoms, but each carbon atom should be bonded to 4 covalent bonds. You look at it properly. We have alkenes, where we have a double bond between 2 carbon atoms. But if now there is already a double bond, then each carbon will need 2 bonds to have 4. Then alkynes, you see each carbon is having 3 bonds already, so it will require one other bond to become 4. So from the definition of hydrocarbons, please note down what I tell you to note. That's what you should read. Only the other things you'll be wasting your time. We shall not ask them. They are for senior 5. Okay, originally they were in the syllabus, but we removed them. We left you with a few. So from the definition of hydrocarbons, we go to alkanes as the first class of hydrocarbons. What are alkanes? We define them as saturated hydrocarbons with the general formula. This is the general formula for alkanes. CN, H2N, 2N plus 2. 2N plus 2 means N is the number of carbon atoms. N is the number of carbon atoms, and N cannot be 0. N is the number of carbon atoms, and N cannot be 0. So we say where N is the number of carbon atoms and N is not 0. So N is not 0 for alkanes. We have defined them as saturated hydrocarbons. They have the general formula CN H2N plus 2, where N is not 0. Or someone can define them, alkanes by saying these are saturated hydrocarbons which have a single bond between the carbon atoms. These are saturated organic compounds. These are saturated hydrocarbons which have a single bond. For them, they have a single bond between the carbon atoms. If you use the formula, then you should mention that N is the number of carbon atoms and N is not 0. So add that one somewhere. Now, if N is the number of carbon atoms, I want us to look at this. It means when N is 1, this one is important. You need to know how to form them. When N is 1, that means the alkane becomes C. Where there is N, you put 1. So the number of hydrogens, it will be, carbon will be 1, and hydrogens will be 2 times 1 plus 2. 2 times 1 is 2, and 2 plus 2 is 4. So the first alkane is CH4, and its name is methane. How are we getting CH4? We are saying the first alkane, the value of N is 1. So we put it in the formula and we get C1H2 times 1, because N is 1 plus 2, and it gives us 4. Now, when N is 2, we get C2, as you can see, but the hydrogens will be 2 times 2, which is 4, plus 2, which is 6, and that is ethane. When N is 3, we shall have C3, then H2N plus 2, 2N plus 2, that means 2 times 3, because N will be 3, that is 6 plus 2, it is 8. So C3H8, and that is propane. We shall stop at carbon atom number 4. When N is 4, in our formula, it becomes C4. Then hydrogen will be 2 times 4, which is 8, plus 2. That makes it 10. So at your level, you need to stop at carbon atom number 4. And that is what we have done. So all this, don't waste your time. Please, all this, don't waste your time. So I said From the definition of alkane, we now look at this table, which is for nomenclature of alkanes. Nomenclature means naming. The word nomenclature comes from naming. So the rest, don't waste your time. So you just come to this molecular formula and structure formula. So molecular formula shows the number of atoms in a molecule. For example, CH4 for methane, it shows you that you have 1 carbon atom and 4 hydrogen atoms. Then structure formula, it shows the arrangement of atoms in a molecule. So you open the structure. So this is structure formula and this is molecular formula. So structure formula, alkanes like hydrocarbons have covalent bonds. So we have already said that they are saturated because they have a single bond joining the carbon atoms. So now this one is molecular formula for methane. We have already seen how it comes about by using the formula CnH2n plus 2. Now to arrange this, we remember that carbon has 4 bonds. So we first write carbon atom and we put the 4 bonds. 1, 2, 3, 4. And the other bonds, those bonds should be attached to hydrogen, such that the hydrogens are also how many? 4. Ethane, we have already seen that it has 2 carbon atoms. So you first write the 2 carbon atoms. They are there. Then each carbon atom now requires 3 bonds such that it can have 4. Because it already has 1 bond between carbon atoms, so you add the other 3 bonds on each carbon atom, such that when you count, each carbon atom has 4. So the other 4, you attach hydrogen to it with hydrogen. Okay. Then propane, it has 3 carbon atoms. When you are writing the structure, first write the carbon atoms. There are 3. Now the first carbon atom, this one, where I'm putting my arrow, my pointer, it requires 3 bonds to have 4. Ensure that carbon has 4 bonds. So this one requires 3 bonds to have 4. So you put those bonds. You first put the bonds, then put hydrogen later. This carbon atom in the middle, it already has 2 bonds, 1, 2. So it requires the other 2 to have 4. So you put 2 bonds. Then this first one, it also requires 3 to have 4 because it already has 1 carbon to carbon. So first count the number of bonds for each carbon atom and make sure that there are how many? That there are 4. So that is how we arrive at structures. All these, don't waste your time. They are not for you. We removed them. We shall ask them in senior 5. So note, the other thing you need to read is molecular formula and structure formula. Full stop. Concentrate on this table. Then from there, we look at properties of alkanes and we look at combustion specifically. When alkanes burn in plenty of oxygen, that is excess oxygen, they all form carbon dioxide and water. Then you balance the equation. Methane plus oxygen, the product is carbon dioxide plus water. But when oxygen is limited, then the product is carbon monoxide. Take note of that. So add this on the list of things you are going to read: combustion of alkanes, and that will be it for alkanes. In excess oxygen, the product is carbon dioxide and water, but in limited oxygen, the product is carbon monoxide and water. That is it for today. I wish you a good day. God bless you.